Hello there. So last week we talked about a couple of important phenomena. We talked about the importance of basically prime factoring for the purpose of evaluating a GCF or an LCM. But the reality is there's a number of different things we can do with prime factorization. So I thought we would just spend today as a foray into all of the different things we can do once we enable ourselves to prime factor. So just a bunch of miscellaneous calculations that will help you out. Let's get started. So the first thing that we will cover is calculating the number of numbers in a factor set, right? And I'm going to go through the detailed procedure, which you can see right here. First of all, you want to start by prime factoring the number, right? So as I go through this procedure, I'm also going to do an example on the right side for you. That way you can sort of keep both in a check and balance situation. So let's go ahead and do an example. Let's pick the... Let's pick this color here. All right. So the question is, how many factors are there in the factor set of 60, right? And then they also ask for how many proper factors there are. Okay, so here's our number 60, right? Ooh, that color does not show up well. Let's try, let's go with this color. Oh, much better. So here's our number 60, and let's begin again by prime factoring, right? So I have here my 2. We know this gives us a 30. Another 2 would give us 15. And 15 we know is prime. It's just going to be 3 times 5. Another 5 out here with a 1. So that means that 30 is equal to 2 squared times 3 times 5. And I'm going to quickly double check using my calculator. Okay, let me try that one more time. Okay, we are correct. We're good. The only mistake is here I wrote 30 by accident, and I should have written 60. So let's erase that, and let's put in a 6 here. Other than that, looks like we're good to go. So now we're on step 2. So we're done the step 1 here. Step 2, write out all the exponents of the individual bases. So let's do that quickly, right? So we know we have an exponent here of 2, right? So here we have 2. And then the power of 3, there's no power given. So we just assume that there's a 1 in hiding over here that we just don't write. So, and when we have 1, and again, same situation, we have another 1. So that's our situation so far. So we're done this step 2. Now the third step is to add 1 to each of these bases. So let's do that quickly. 2 plus 1 is 3. 3 plus 1 is equal to 4. And, sorry, not 3 plus 1. 1 plus 1 is equal to 2. And again, 1 plus 1 here is equal to 2. That's step number 3. And step 4 is to multiply all these new bases together. Let's do that. Right? There is one correction. You multiply each of these new exponents together, and you add 1 to each of these exponents. Okay, so that is a quick clarification to make. And then we go ahead and do this. 3 times 2 is equal to 6. 6 times 2 is equal to 12. And so we know that 60 has 12 factors, right? And of course, you know you would need to find these factors by either doing it in pairs or in order. So that would be the next step probably in this question, right? So as it says here, this final number will let you know how many factors are in the factor set. Okay, so that is the first cool thing we can do with prime factorization. All right. Now we're going to find the largest factor where they give us this restriction where all the numbers have to be unequal and greater than 1. So again, the first step is always going to be the same. We need to prime factor the number. So let's go ahead and do that. Here our number is 10,500. Okay, let's go through with this. So let's start with 2. So of course this is even. So that gives us 5250. Same idea. This is probably the world's worst 0, so let's fix that. You can divide it by 2 again, and you get 2625. This is now no longer divisible by 2, so it is divisible by 3. You go ahead and you do that, and you get 875. Can we do this again? We cannot. That gives us a decimal. So we need to divide it by 5, which seems like a good thing to do. We get 175. Again, we can divide it by 5. We get 35. Right? And at this point, this is pretty easy. We know it's just going to be 5 times 7. I'm going to put the 7 out there, and I will barely squeeze the 1 in there. Okay? So our prime factorization in exponential form looks like 2 cubed, multiplied by, let's just quickly check this as well. Sorry, this is a 3 here, not a 2, because we needed to divide by 3. This is obviously not even, so just be careful about that. So 2 squared, not 2 cubed. Multiplied by 3, multiplied by 5 cubed. There are 3 of those, multiplied by 7. So this is a nice sort of big number to deal with, which is good. And then now we have to divide this between the first few numbers, right? So in this case, we're going to end up having 4 numbers, as it says here in the question. So 1, 2, 3, 4. Now let's pick this one to be the largest. That means these 3 have to be very small, right? Because if you're going to reserve one number to be very big, only you can multiply by all the small numbers to get the same overall number, right? So you have to keep that in mind. And now for the small numbers, we will try and distribute prime factors, you know, sort of like the Drake outline hotline bling video, and try and be as conservative as possible. Because remember, we have 2 restrictions. First of all, we can't use 1, because if we used 1, it'd be easy. We just do this, 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 and then 10,500 here, and we'd be done, because that is going to obviously be the biggest number. But you can't use that because it says so in the question. We also can't repeat any number, so you can't do this, for example. You can't just put 2 2s like this. They all need to be unique, right? So let's go ahead and try that then, right? First of all, we're going to put a 2 here. 2 is the next biggest number after 1, so if we can use a 2, we're going to do that for sure. Right, so basically we have 1 2 left over here, so I'm just going to quickly cancel this out and put a 2 out here. Now this remaining 2 we're not going to use yet, because I want to use the 3. 3 is the next smallest number, so obviously you go 1 2 3. So let's put a 3 in there, and then that 3 is just gone. So that is that. Next, we can think about what we're trying to do here. Obviously, you want to keep this number as small as possible, but we've sort of already burned through the 2, and we've burned through the 3. So they're not going to work anymore, right? So we can combine other prime factors too. So for example, over here, we can have like a 7 or a 5 or whatever it is that we need. And in this case, I'm just going to pluck out a 5 from here and use that, right? So we have a 5 squared left over here. So we get 2 times 3 times 5 in our first 3 smallest numbers. And we can do a quick check. Really the 2 and the 3 have to be right, because there is no smaller number. And then if you move forward, there's no way we can make a 4, right? Because the only way to make a 4 would be to have 2 2s. We already used 1 for the first one. So that goes out the window as well. So we have 2 times 3 times 5. And left over is this leftover 2, this leftover 5 squared, and this leftover 7. So let's go ahead and multiply those things together. 2 times 5 squared times 7, which gives us a value here of 350, right? And that is going to be the largest possible number in this situation, because we sort of picked and choose, and we picked and choose these values to make them as big as possible towards the end, which means making them as small as possible towards the beginning, right? So, I mean, that is what we would come up with in this question, right? But the important thing, obviously, is that the first step in this question is to prime factor the number. You've got to do that first, okay? All right, let's do a quick double check. And 2 times 3 times 5 times 350 gives us our desired value. Looks like we are good to go. Alright, so the next thing we're going to talk about is numbers dividing into other numbers, right? So our first step remains identical. We need to prime factor both of these numbers. So let's go ahead and do that. Here it's actually pretty easy because we can use our 2's and 5's trick from that very, very first lesson. So if you remember, the number, let's just put it up here, I guess. The number of terminating zeros each give us 1, 2, and 1, 5. That is the situation. So let's see how many we have here. Of course, it's going to be like 1. So because 1 doesn't do anything, we don't have to worry about that. But for 100,000, right, this has 1, 2, 3, 4, 5 terminating zeros, which means it's going to be 2 to the power of 5 multiplied by 5 to the power of 5. No need to do all that upside down division stuff when you don't have to. So do keep that in mind, okay? It's going to be a super effective strategy. All right. For 1,000, same idea, but this time we only have 3. 1, 2, 3, which gives us 2 cubed times 5 cubed. Just like that, the first step is done. Second step, create an improper fraction using the two numbers at hand, right? So basically that means the big number goes on top and the small number goes on the bottom, right? So we can do this in basically in one of two ways. I'm just gonna put them on top like this. Right? So that's step 2. Step 3, in the fraction, instead of having actual numbers, we're going to replace them with the prime factorization. Let's do that. So instead we have 2 to the power of 5 times 5 to the power of 5 over 2 to the power of 3 times 5 to the power of 3. Right? And then step 4 is to cancel out. I'm actually going to write these now in the non-exponential form to make it easy for you to see what cancels with what. So we have 2 times 2 times 2 times 2 times 2. That's 5 of them, times 5 times 5 times 5 times 5 times 5. Wow. Right? And the denominator, we've got 2 times 2 times 2 times 5 times 5 times 5. And let's go ahead and cancel out. Donk, 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 donk. And 5's donk, 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 donk. Right? And now the remaining number that we have left over is obviously 100 because we have 2 5's and we have 2 2's. Right? Now we do our last check. 100 is obviously a whole number, which means that yes, 100,000 is divisible by 1,000. And it's easy to see that from the etymology of the numbers, right? 100,000 literally means having 100 and multiplying it by 1,000. It's literally 100 groups of 1,000. That's why it's 100,000. So this answer makes perfect sense. All right. Now, the last thing I believe that we will cover is a number a perfect square using the basis of prime factorization. So of course, number 1, we have to prime factor. Let's go out there and do that. So I have a pretty big number here, 167, 9616, and even though it's a big number, our strategy is not really going to change. So let's just continue doing it the same way we do all the other big numbers, right? First divide it by 2, so we have 79, 616. We divide that by 2, whoops, and we get 839808. Which is still even. So let's divide by 2 again. We get 419904, which is also even. We get 209952, which is also even. We get 104976, which is also even. I'm going to run out of room, so I'm going to start using this here. When we do divide it by 2, we get 52488, which is, surprise, surprise, also even. Gives us 6244. Which gives us 13122. So far we haven't had to use anything else. Which gives us 6561. And finally, that's it. We're out of 2's. Okay? So where we got is 6561. So 6561 is actually divisible by 3. So let's go ahead and do that. Which gives us 2187. I'm going to run out of room again, I think. Dividing it by 3 gives us 729. Which we can do again, which gives us 243. Okay, let's use this now. Alright, and we divide that by 3 again, we get 81. We can divide that by 3 again, and we get 27. And so on, we get 9, which gives us 3, which gives us 3, which gives us 3, which gives us 1. Right? So, this is a gigantic prime factorization. Let's just write it up over here, and then I'm going to move it back down. So we have 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8. And we have 3 to the power of 1, 2, 3, 4, 5, 6, 7, 8. Okay. So when you get a really big prime factorization like this, it's a really good idea to just go back and check. So I'm going to enter this into my calculator. 2 to the power of 8 times 3 to the power of 8, which gives us 1679616, which is exactly the number that we had in the first place. Okay? I'm going to erase all this prime factorization, but hopefully it was cool to kind of go through a really big number. Let me grab my eraser here. Okay, this is going to be a... And we're just going to write this a little nicely now that we've gone through the entire mathematical calculation, which is that 1679616 is equal to 2 to the power of 8 times 3 to the power of 8. Right? And we don't need this anymore either. Cool. So now is the actual question. So all that was just the preparation, unfortunately. We've got to do the actual question now. Now, if it's a perfect square, all your prime factors will be even, right? So that's what we're looking for. And it's not just the prime factors, it's the exponents of the prime factors. So here our exponent is 8, and here obviously, of course, our exponent of 8, and both of these are even. Which means that, yes, this is absolutely a perfect square. Right? And just to check, the square root of 1679616 is actually equal to 1296. So that's that. Sorry, that was a very bad arrow. Okay. That's it. Thanks for coming out.